let's discuss very important concept that why we use particularly these type of energy sources in XPS analysis. We know that the maximum binding energy of all detectable elements are in this range, or the major photoelectron peaks or OJ electron peaks are below 1200 electron volts. The photoelectron peak's binding energy is independent on the X-ray source. If you use magnesium or if you use aluminiums, the photoelectron peaks are independent while the OJ electron peaks depending on the X-ray sources. We know that when we shine X-ray on the sample and the photoelectron eject from the sample, this is now the photoelectron here, and this photoelectron has certain kinetic energy, and this photoelectron, let's suppose this is the nucleus here, let's suppose this binding energy is 1000 electron volt, 1000 electron volt. So this binding, look at this equation, this is the known X-ray source energy if you use here magnesium or if you use aluminium here, this is known here, and this is also the work function of the spectrometer constant value here. Now this binding energy has nothing to do with X-ray source. For example, we need here at least the X-ray source greater than 1000 electron volt to emit this electron from the shell. So it has nothing to do with the X-ray source. If we use, for example, 2000 electron volt X-ray source, we have nothing to do with this. The binding energy is there. The binding energy is the intrinsic property, so it is not changing or it is not affecting with the changing with the X-ray source. But the OJ electron, when the OJ electrons binding energy depend on the X-ray source, I am not going to explain that why OJ electrons binding energy is dependent on the X-ray source. This is not I am going to answer. Let's discuss the common X-ray sources used in XPS analysis. We know in XPS we bombard X-ray of known energy and photoelectrons are generated. So there are two types of X-ray used in XPS. There is a logic behind this video, very important concepts. One is magnesium K alpha-line, this is the PEX energy. Another is aluminium K alpha-line, this is the PEX energy. I want to clarify that the maximum binding energy for all detectable elements below 1200 electron volts. So this is one reason that we use X-ray sources greater than this binding energy. Otherwise, we won't have these photoelectrons. Otherwise, the photoelectrons will not emit from the samples. If you use, for instance, 900 electron volt X-ray source, if you use 1000 electron volt X-ray source, because that energy is not sufficient to escape to remove electron from the core shell. Another important point is we know in XPS spectrum we have two major peaks. One is the photoelectron peaks, another is the OJ electron peaks. These are the common peaks. So the photoelectrons binding energy is not depending on the X-ray source. If we use magnesium source or if we use aluminium source, the photoelectron binding energy is independent. I will explain this. The second important thing is the OJ electron binding energy is depending on the X-ray source. Very interesting. This is the standard XPS spectra for tungsten. Here we use Mg K alpha source here, and we can see that the energy range from 0 to 1200. And this range, major OJ peaks as well as photoelectron peaks are appear here. This is basically the OJ peak here, and all these are basically photoelectron peaks here. And this is we call survey spectra. So this means that this Mg K alpha source is sufficient to remove maximum photoelectron and OJ electron from tungsten here. This is the high resolution XPS spectra for this particular peak here. We can see that the peaks are now look separate here, and this peak is locating exactly at 31.4 binding energy. When I change this X-ray source, instead of magnesium I use aluminium, this binding energy for this particular peak will not change. there will be no change in this particular peak binding energy in the range will be from 25 to 45 electron volt. You will note it here when I use aluminum as a X-ray source. Now let's take this OJ electron peak, and when we take the high resolution XPS spectra, so there are many peaks here. Now the peaks range from 1050 to 1100. Now when I replace the X-ray source, now if I use aluminum here, so you will see this range will change. Look at this image. Here the sample is same tungsten, but we just change aluminum, the X-ray source, and it is clear from this range from 0 to 1400. And here we also get the major peaks here. This is photoelectron peaks, and this is the OJ peak. Now look at the high resolution XPS spectra. These peaks binding energy is not changed. It's from 25 to 45. This means that the photoelectrons binding energy is independent on the X-ray source. If you use aluminum, if you use magnesium, but the OJ electron peak, this is the high resolution for OJ electron peaks, and it was from 1050 electron volts, and here now it starts from 1280. This is why when we change X-ray source, the OJ electron peaks change, or the OJ electrons binding energy change, while there is no change in the photoelectrons peaks or photoelectrons binding energy.